A hole about the size of Switzerland or South Carolina keeps popping up in the Antarctic ice. This opening is growing steadily, and it took scientists half a century to figure out why. They found the answer with the help of seals. The scientists first spotted this gap, called Maud Rise Polynia, in the Weddell Sea in 1974. They were about to close the case as the hole disappeared, but it popped out again in the following 2 years, and then only in 2016. The giant hole is near Maud Rise, an underwater mountain. This type of hole is a polynia, a rare patch of open water surrounded by thick sea ice. In Antarctica, when winter hits, the ocean surface freezes, and sea ice spreads out to cover an area about twice as big as the continental United States. Along the coast, openings in the sea ice pop up every year. This happens when powerful coastal winds blow off the continent and push the ice away. But it's a whole lot rarer for these openings to form way out over the open ocean, hundreds of miles from land, where the water is thousands of feet deep. Researchers from several universities teamed up to study the Maud Rise Polynia using computer models and satellite images. They even recruited some Antarctic seals to help out. These seals wore tiny helmets on their furry round heads with tracker sensors attached to them. Thanks to these sciencey seals, the team could collect water data from the source. After the research, the scientists discovered that the hole resulted from a complex mix of factors. The wind, ocean currents, and the special shape of the ocean floor all work together, moving heat and salt up to the surface. In science talk, this swirling movement is called an Ekman transport. Ekman transport is what happens when wind messes with the surface of the ocean. When the wind blows across the water, it creates friction that grabs onto the top layer and pulls it along. Thanks to the Coriolis effect, which comes from Earth's spinning, the moving water gets pushed at a 90-degree angle from the wind's direction. So, instead of the water going exactly where the wind is pushing it, it drifts off at an angle. Which way it turns depends on which half of the planet you're on. In the northern hemisphere, the water shifts clockwise from the wind direction, and in the southern hemisphere, it shifts counterclockwise. Now, Ekman transport turned out to be the missing piece of the puzzle in the case of the Maud Rise hole. It helped balance the salt levels and keep mixing salt and heat up to the ocean surface. But as the sea ice melts, the surface water becomes less salty, which should stop the mixing. So the scientists realized something else had to be happening to keep the polynia open. There had to be another source of salt. Salt lowers the freezing point of water. To find out where this extra salt was coming from, the team dug back into their data and ran more computer models on the ocean. They found that swirling currents formed as the Weddell current flows around Maud Rise. These currents carry salt up to the top of the underwater mountain. From there, Ekman transport kicks in. As the top layer of water moves away with the wind, water from deeper down rises to take its place. At Maud Rise, this upwelling water brings along the extra salty water built up around the seamouth, and that's what helps keep the polynia from freezing over. Scientists follow any changes in Antarctica as they influence the rest of the world. Researchers at Stanford University used machine learning for the first time to study detailed satellite data showing how ice moves in the polar region. They combined huge amounts of real-world data with physics rules to understand the Antarctic ice sheet better. It's the biggest ice mass on Earth, almost twice as large as Australia. It acts like a giant sponge for the planet, storing fresh water as ice and stabilizing sea levels. Scientists used to rely on models based on lab experiments, but real Antarctic ice is way more complex, with cracks, air pockets, and different types of ice that behave unpredictably. Instead of trying to model every little detail, the team trained a machine learning model using data from 2007 to 2018. It looked at 5 major ice shelves and created new models showing the ice's resistance to flow. They found that near the land, the ice is compressed and behaves as in lab predictions. But farther out, the ice is stretched toward the ocean and acts differently depending on direction. Less than 5% of the ice shelf is compressed. The other 95% behaves in a way old models didn't fully explain. This research could seriously improve our predictions of how Antarctica might change in the future. Another recent piece of big scientific news from Antarctica changes the history of birds as we know it. For a long time, it was simple. Dinosaurs ruled the Earth until an asteroid hit 66 million years ago and wiped them all out, except for some avian dinosaurs, which eventually became birds like eagles and chickens. Now, scientists have found a headless fossil of a VYI on Vega Island in Antarctica. The fossil was 68 million years old, at least 2 million years older than the asteroid strike. Without a skull, it was unclear what modern birds VYI might be related to, and guesses included waterfowl and shorebirds. Nearly 20 years later, another expedition found a bird's skull in Antarctica. After careful study, scientists matched it to VYI and concluded it was an ancestor of modern water birds like loons and grebes. If it's all true, VYI is now the oldest known modern bird in fossil records. The skull had a long, pointed beak, a brain unlike any other Mesozoic bird, and signs of strong jaw muscles like mine, which were perfect for diving underwater and catching fish. The body fossil also had adaptations for underwater swimming, similar to modern diving birds. During the late Cretaceous period, Antarctica was a temperate rainforest, far from the Yucatan, so it could have become a safe haven during the asteroid disaster. So, early modern birds might have survived there. When a giant iceberg, about the size of Chicago, broke off from Antarctica's massive ice shelf, scientists nearby did something no one had ever done before. They sailed straight over to check out the newly exposed seafloor. Studying the undersides of ice shelves is incredibly hard, but thanks to the iceberg A84, a 209 square mile patch of seafloor suddenly opened wide for exploration. The scientists deployed all their high-tech gear, including a remotely operated submersible and autonomous robots, to collect data about the seafloor and the properties of the water above it. Life exists almost everywhere in the ocean, from the bright, shallow waters to the pitch-black, volcanic deep sea. But the research team was really surprised to find such a diversity of life down there. They found a forest of sponges, giant sea spiders, ice fish, octopuses, huge corals, anemones, and even glowing deep-sea jellyfish. Normally, deep-sea creatures get their nutrients from organic matter falling from the ocean surface. But under a 500-foot thick sheet of ice that had been there for who knows how long, that wasn't possible. That meant the creatures had to be getting their nutrients in some completely different way. To figure out how long this hidden ecosystem had been around, the scientists studied the sea sponges. Sponges grow extremely slowly, only about an inch per year, but the ones they found were huge, so they must have been growing there for decades or even centuries. The team is hoping that the mountain of ocean and environmental data they collected during the expedition will help them understand how these ecosystems managed to thrive in those conditions and maybe reveal some completely new species that no one has ever seen before.
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian Plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian Plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian Plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian Plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian Plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where two or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the seafloor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya, first in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into two subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today. Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue. Much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer. They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on two tectonic plates. The Nubian one carries most of the continent. The smaller Somali plate holds the Horn of Africa. The crevice in Kenya appeared in the Rift Valley between these two plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into two. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be two African subcontinents. They will be separated by a body of water that will become our planet's 6th ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. The world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The two act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only 2 places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The 2 continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed 1 billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the Earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land: Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed, then bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so Doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists.